All right, we're looking at sum of samples and sample means for discrete variables, and this will be almost exactly the same as what we did in continuous variables. We have these formulas. Just as a reminder, Sn is when you take a group of n things and look at the sum. Xn is the averages. So with this, you got a discrete random variable, all that stuff. So the mean of x bar 8 is the same thing as the mean of x, which was 2. And the standard deviation of x bar 8 is the same as the old standard deviation over root 8. And if we work that out, let's see. So that would be 3 over root 8. And then we can just chuck that into a calculator and get our answer. All right, 1.06. You might notice the mean is the same and the standard deviation is less. Okay, for S8, the mean is going to get bigger. So this is 8 times the old mean. So this is 8 times 2, which is 16. And so that was the mean of S8. For the standard deviation of S8, we've got, this is root 8 times the old standard deviation. This is root 8 times 3. And we can work out what that is. So root 8 times 3, 8.49, approximately. Okay, that's good. Suppose I buy eggs in cartons of 12, and some of them have double yolks, and each carton on average has 1.7 double yolk eggs. So it might have a whole bunch with 2, some with 3, a couple with 1. I know double yolks aren't actually this common, but bear with me for this example. Find the mean and standard deviation if I buy 5 dozen eggs. So let x be the number of double yolks in a dozen. So we've seen that the mean of x is, let's see, 1.7. And the standard deviation of x is 0.4. And we're looking at 5 dozen eggs. So we're looking at S5. This is the number of double yolks in 5 dozen eggs. So you might expect that the mean would be 5 times 1.7, and you would be right. 5 lots of 1.7, we can work out what that is. You'd expect 8.5 eggs out of here to have double yolks, and these really should have units on them, same as these. Okay, now the standard deviation of S5 is root 5 times the old standard deviation. So that's root 5 times 0.4, and we can work out what that is. So what we get is 0.894. Oops. Done. Now we got this spinner here, and it's got a 1/3 chance of being blue and a 2/3 chance of being red. All right, spin it once and let x be the number of blue, make a table of probabilities. So we're going to spin this once. So x could be a 0 blue or 1 blue. And the probability that big X equals little x is, well, for 0 blues, it's a 2/3 chance, and for 1 blue, it's a 1/3 chance. Okay, what type of distribution is this? I really would encourage you to pause the video and actually think about what type of distribution it is. Hopefully you did that. This is a Bernoulli distribution with P is 1 out of 3. Now, if you had said a binomial with n is 1 and p is 1/3, you would also be correct. Either of these are fine. Bernoulli distributions are just binomial distributions with n equals 1. Calculate the mean and standard deviation for x. Since this is a Bernoulli variable, we can just use the formulas. So expected value of x is p, which is 1/3. And the standard deviation of x is, I think that was root p1 take p from memory. Okay, so that's root of 1/3 times 2/3. Oh, by the way, if you use the binomial distribution formulas, you get np in there, but n is just 1, so it doesn't change anything. It all works out. Funny about that with maths. Anyway, this is, let's see, root of or 1 out of 3 times 2 out of 3, which is root 2 over 3 or 0.471. 0.472, I think, if I round it. Okay. Let's check that. 0.47. No, 0.471 was fine. Now, okay, let's pretend that you forgot what a Bernoulli variable was and you didn't know these formulas. What you can do is you could go into menu on your stats and we could enter these two lists. So just 0 and 1 there. And if we delete out that list, 2/3 and 1/3. We're going to calc 1 var. Well, we should set and make sure we get the frequency list and then go 1 var 0.333. That's correct. And the standard deviation was 0.471. So the calculator agrees with us, which is always good. If I spin it 5 times, calculate the mean and standard deviation. So the expected value of S5 would be 5 times 1/3, right? So that would be, I reckon, well, I'm not going to try and guess that. 5 times 1/3. 1.6, I reckon, maybe. Good. So 1.6 recurring. And I guess since I gave the other one as decimal, I'll keep this one as decimal as well. And then the standard deviation of S5. This is root 5 times the old standard deviation. And let's see what we get there. Root 5 times, I'm going to use the full version of this number, 0.471404528. And we get 1.05. Wonderful. Okay. What type of distribution is S5? Yeah, I would really encourage you to pause the video and think about it. You've got blue and red. Then you've got to spin it again and get blue and red. For each of those spins, you're going to spin it again and get blue and red and blue and red, and blue and red and blue and red and blue and red. We've got 2 outcomes each time. We've got a fixed probability on each one, so these will always be 1/3, 2/3. This is a binomial. N would be 5, and P would be the chance of getting a blue, so 1 out of 3. So binomial distributions are just like the SN version of Bernoulli distributions.